Here are some patterns when it comes to the sum and difference of two binomials being multiplied, the square of a binomial and the cube of a binomial. For example, if I were to take the quantity 2x minus 3 and multiply it by itself, I could follow the pattern of the square of a binomial. If I use that, a is 2x and b is 3. So my expansion would be a squared is 2x as a product squared minus 2 times a times b, so times 2x times 3, plus b squared, 3 squared. This simplifies to be 4x squared minus 12x plus 9. Instead of needing to memorize the expansion for the negative versions, you can use the same expansion for the positive. Just remember that b may have a negative. So in that case, if I were to use this formula, a would be 2x and b would be negative 3 because it would be plus b, so plus a negative 3. This would expand to be 2x product squared plus 2 times a times b, which is negative 3, plus b, which is negative 3, squared. And this will actually give you the same exact expansion. Don't forget there's a negative there. And you wouldn't need to memorize or recognize the negative versions of these expansions. But what if I have a quantity like x plus y to the 7th power? Does that mean I have to distribute x plus y times x plus y times x plus y times x plus y 7 times? Oh, that's going to be a lot of work and a lot of areas where I could possibly make errors. So let's take a look at a special array of numbers that can help us with the pattern of binomial expansion. And this special array of numbers is called Pascal's triangle. Like I said, Pascal's triangle is an array of numbers in a special arrangement. The arrangement looks like a triangle. We're going to start with the 0th row. The 0th row has a 1. And we're going to build it out just similar to a pyramid. 1 and 1 would be our first row. In order to create the next row, we always start and end with the number 1, but the number in between here is the addition, the sum of these two. So 1 plus 1, 2. And again, we always start and end with 1. The third row starts with 1, but then what term goes here? Underneath, but between the 1 and the 2, that would be 3. Here, 2 plus 1 is 3, and 1. The fourth row, 4. 3 plus 3 is 6. 3 plus 1 is 4, and we end with 1. See if you can fill in the 5th and 6th rows on your own, then press play to check. This problem asks us to use Pascal's triangle to expand this binomial. This binomial is x plus y to the power of 5. So I'm going to look at the 5th row of Pascal's triangle because the power that I'm expanding is to the power of 5. That's why it's important to know that the very top row with just a 1 is actually called the 0th row. So the numbers in the 5th row will either be our coefficients or will be multiplied by the other numbers in each of those terms. So these numbers 1, 5, 10, 10, 5, and 1 will be an integral part. They will be multiplied by each term that they're attached to. Okay, so let's start off with the very first term they're attached to. This is the first term, and this is the second in our binomial. The sum of the exponents must always equal 5. So I go first term to the power of 5, which means the second term is to the power of 0. 5 plus 0 is 5. This is the first product, the very first term in our expansion. Now, x is going to be to the power of 1 less than what it was before. So now it's descending. It's going x to the 4th. The sum of the exponents must still be 5, so y is to the power of 1, which means the exponents of x, the first term in the binomial, will be descending as the exponents of y, the second term in the binomial, will be ascending. Attached to the 10, I should have an x to the power of 3 times y to the power of 2. Attached to this 10, x is descending, so now x is to the power of 2. Y is to the power of 3 because y's are ascending. X is now to the power of 1, and y is to the power of 4. Again, the sum of those exponents must always be 5. And then x to the power of 0 times y to the power of 5. To simplify, the first term is 1x to the 5, y to the 0, so that's just x to the power of 5. The second term is 5x to the 4, y to the 1. The binomial we needed to expand had a sum rather than a difference, so all of our signs will be positive. But when there's a difference, it's important to take that into account and watch out for your signs in between each of the expanded terms. Plus our next term, all right, this is the expansion of x plus y, quantity to the power of 5. As you can see, because the first term was a variable, the second term was a variable, and neither of them had a coefficient, that the coefficients for our expansion are the numbers in the 5th row of Pascal's triangle. But if you have a coefficient on this x or a coefficient on this y, that will end up changing the resulting coefficients of the expansion. Use Pascal's triangle to expand 3x minus 1 to the power of 4. First of all, what is the power? 4. So I need to expand using the numbers in the 4th row of Pascal's triangle. The first term of the binomial is positive 3x. The second term of the binomial is negative 1. Ooh, now we have a negative and we have a coefficient for x. To start off, we put the first term to the power that you see here. So it should be 3x to the power of 4, which means that negative 1 is to the power of 0 because the sum of these exponents must always equal the power to which we're expanding. Next, the power of this first term will descend as we continue on, and the power of negative 1 will ascend as we continue on. 3x is to the power of 3, so negative 1 is to the power of 1. 3x is to the power of 2, so negative 1 should be to the power of 2. 3x to the power of 1, and now negative 1 is to the power of 3. 3x to the power of 0, negative 1 to the power of 4. Our first term is 3x as a product to the power of 4 is 3 to the power of 4 times x to the power of 4. 3 to the power of 4 is 81, so that should be 81. 3x as a product being cubed would be 27x cubed times a negative 1. This negative 1 is part of the product. It's not 27x cubed minus 1. It's all of this being multiplied. And so if it's negative 1 to the power of 1, that makes the result of this product negative. And that's why I leave the spaces, because it's not always plus, and so I don't want us to forget. I want us to take into account if this is a minus, then the signs will alternate for all the other terms, positive and negative. 3x as a product squared is 9x squared. And now we have a negative 1 squared. So this is a positive, which means the sign we get here is a positive. 3x to the power of 1 is just 3x. Negative 1 to the power of 3, that results in a negative, and so that will give me my negative sign. Then 3x to the power of 0 is a 1. You don't have to write that, but negative 1 to the power of 4 is a positive. So this puts a plus in front of this final term. Let's do the rest of the simplifying by multiplying any numbers that we have left. So as you can see, the orange numbers are the numbers in the fourth row of Pascal's triangle, but they will not be the end result coefficients because of the coefficient of 3 on the x. All right, that last step will be 81 x to the fourth, 108 x cubed plus 54 x squared minus 12x plus 1. We had a minus inside of the binomial, which means the signs are alternating, plus, minus, plus, minus, plus. And this is the resulting expansion for 3x minus 1, quantity to the fourth power.